Okay, so the next topic is Cramer's rule for solving linear system. So Cramer's rule for solving a linear system. So this is a very interesting method. So suppose we have represented our linear system by uh, following some kind of coefficient matrix. So let's say let's take some general case, and a21 a22, so those are just coefficients, and let's say we have n amount of equations a n a, and we have unknowns x1 x2 so on up to xn. So this will be equal to some given constants or some known constant values. So this is just a basic coefficient matrix, coefficient matrix representation. So in the Cramer's rule, it says that in any given arbitrary, any selected arbitrary unknown will be given by using this method. So determinant of this A is basically the determinant of this coefficient matrix, and this AI is the new thing. This AI is basically uh, a new determinant of a new matrix, which is obtained by replacing a relevant rule from this matrix, from this column matrix, by replacing a relevant column, by replacing uh, by uh, by replacing a relevant column using this column matrix. So in this case there will be n amount of column replaced uh, new matrices. So we have to find out each and every new matrices and their determinants in order to find out the unknown list. So that is the Cramer's rule. The only new thing is we are obtaining a new matrix by replacing a relevant column from this given constant value, given constant column matrix. So suppose let's take an example. So let's say we have a very simple linear system like this: a2x1 x2 equals 5, and 3x1 plus 2x2 equals 11. So let's find out x1 and x2 by using Cramer's rule. Cramer's rule. So this is the Cramer's rule, AI determinant of A. So if we wanted to find out x1, then we need to find out determinant of A1 and A. If we wanted to find out x2, then we need to find out determinant of A2 and A. So first let's find out determinant of A. So before everything we have to write our coefficient matrix representation. So it will be 2 minus 1 3 2, and the unknown list x1 x2, and the constant list 5 11. So this will be A, this will be X, this will be B, some kind of a B matrix, column matrix. So determinant of A is very we can write it as 2 minus 3 minus 1, then 4 plus 3, which is 7. So now we know the determinant of A. Then all we have to identify the replacing matrices and their determinant values. So in the first case A1, so we have to replace the first column by this uh, B column matrix. So it will produce some matrix like this: 5, 11, minus 1, 2, because we replaced the first column with this B column matrix. So the new determinant will be 5, 2, minus 11, minus 1, which is 21. Then x1 will be a1a, so 21 divided by 7, which is 3. So this is the answer for x1. So likewise x2, so we have to find out a2. So a2 will be replaced, will be constructed by replacing second column by this B column matrix. So it will be like 2, 3, 5, 11. So the determinant value will be 2, 11, minus 3, 5, which is 22, minus 50, which is 7. So the corresponding x2 will be something like this: 7 divided by 7, which is 1. So that is how we solve a linear system by using Cramer's rule. All we have to identify this coefficient matrix, this coefficient matrix, and this determinant value, and their corresponding newly constructed replaced matrices determinant values. These are newly replaced determinants. So if we have n number of linear equations, then there will be n number of unknowns as well. So we have to proceed this exact same procedure in n times. So that's how we use Cramer's rule.